So this is the Chapter 9 Review 1 video key. So I'm going to go ahead and work through the problems. And so if you're struggling or maybe you didn't know how to solve them, this is a good way to see how each problem could be solved. So solving using the square roots. So to remember, to solve using the square roots, the idea here is we have to isolate our variable, meaning we have to move everything away from it. So you'll start problem 1 by adding 72 to both sides. You'll get 8x squared equals positive 72. To isolate the x squared, you'll then divide by 8. And you've got x squared equals 9. Your last step of this would be to square root both sides. And in this case, you're going to get x to equal 3. But remember, you're solving for the square root, and anytime we square root something, we end up with two answers, the positive and negative version. So your answer here is x equals plus or minus 3. Question 2, you'll do the same thing, except this time we've got to move the 49 to the other side by subtraction. So we'll subtract 49 from both sides. Here we've got x squared equals a negative 49. The only issue here is when we try to put negative 49 square rooted into our calculator, we get an error because we cannot square root a negative number. So this ends up being no solution. Question 3, very similar. We're going to start the problem off by trying to isolate the x squared by moving the 1,521 to the other side through addition. And so we've got 9x squared equals 1,521. We'll then divide by 9 on both sides of the equation. And in this case, we get x squared equals 169. And then we just need to square root both sides. Well, the square root of 169 is 13, so our answer becomes x equals plus or minus 13. For questions 4, 5, and 6, we're going to solve by factoring. Question 4, the thing you should notice first is that the terms all have a GCF of 2 in common. So if you want, you can divide the entire problem by 2 just to make it easier. In doing so, you get x squared minus 2x minus 3 equals 0. So this is going to be the quick factored form, where you're trying to find the factors of negative 3 that add up to be negative 2. Well, that's going to be x minus 3 and x plus 1. So your factors have to be a negative 3 and a positive 1. And so now that we have this factored, we can set each piece equal to 0 and solve. So x minus 3 equals 0 and x plus 1 equals 0. So in this case, for x minus 3, we would add 3 to both sides, and we're going to get x to be 3. For x plus 1, we'll subtract 1 from both sides, and we get x to equal negative 1. Question 5 is very similar. We don't have our leading coefficient is 1, so it's 1x squared, so that means we can do the quick and easy factoring method, where we look at the factors of negative 8 that add up to be a positive 2. Well, two numbers that multiply together to give you negative 8 and add to be 2, well, that's going to be a positive 4 and a negative 2. So our factored form becomes x plus 4 and x minus 2 equals 0. Now we want to set each piece of this equal to 0 and solve. So x plus 4 equals 0 and x minus 2 equals 0. In both cases, we're going to solve for x. So in the first case, we subtract 4 from both sides, and we get x equals negative 4. In the x minus 2 side, we've got to add 2 to both sides, and we get x equals 2. Question 6 is a little different because we have a leading coefficient in this case, which is 3. So it's greater than 1, so that means we have to use slide divide factoring. So we're going to slide this back through multiplication. That gives us x squared plus 10x. Let's change the color of the pen first. X squared plus 10x minus 24 equals 0. So now we're kind of doing this like the previous problems. We're looking for the factors of negative 24 that add up to a positive 10. Well, that's going to be a negative 2 and a positive 12. So we've got x plus 12 and x minus 2. Remember, we had a leading coefficient of 3, and we used slide divide, so that means we have to now divide our factors by our leading coefficient. If the numbers are divisible by the coefficient, in this case 12 is divisible, we go ahead and divide. So we get x plus 4. If it is not divisible, we bring it out in front of the variable. And so the other quantity, we get 3x minus 2. And so this is our factored form. So our last step is to set each of these equal to 0 and solve for x. For x plus 4, we'll subtract 4 from both sides, and we get x to be negative 4. For 3x minus 2, we're going to add 2 first. So we'll get 3x equals 2. Then we'll divide by 3, and we get x to equal 2/3. So our two answers here are negative 4 and 2/3. In the next section, questions 7 through 9, they want us to solve by graphing. Well, to solve by graphing, I remember that one of the easiest ways to start graphing is to look for my axis of symmetry first, which in this case, my axis of symmetry has the same equation for all of these problems. It's going to be, or it has the same formula to find the equation, and we use x equals negative b over 2a. So for number 7, our b in this case is going to be negative 4, so negative b would be a positive 4 over 2 times 2, because a is 2. So that means my axis of symmetry is going to be x equals 1. That value is also the x value of my vertex. So I know for my vertex, I already know that my x value is 1. To find my y value, I just need to plug it back into the equation and then solve for y. So 2 times 1 squared is 2, minus 4 times 1, which would be negative 4. So 2 minus 4 is negative 2, minus 6 would be a negative 8. So my vertex is the point 1, negative 8. I also know that my y-intercept in this case is the point 0, negative 6. And so I can kind of plot what I have so far. I've got my vertex at 1, negative 8. Through that point, my axis of symmetry runs. So don't forget about that, because that's really important. And then I also know that I have my y-intercept at 0, negative 6, which is this point here. And I can mirror it over here. But I need other points. So I would use my graphing calculator or an x and y table or Desmos, and I would find additional points. And so when you're looking at a table, the key points to look at here, because we're trying to find solutions, are anytime you have a y value of 0. Well, as I was looking at my table, I knew that if I had the value at negative 1, my y value was 0. And if I had the x value, or the x value at negative 1, my y value was 0. And if I had the x value at 3, my y value was 0. So that means I have points here, one too many, right here, 3, and negative 1. And so my parabola looks something like this for question 7. And I know that my solutions take place here and here. So that means my answers, in this case, are going to be x equals negative 1 and x equals 3. And I'll kind of do the same thing for the other problems. So like in question 8, I would start off by finding my axis of symmetry. So x is going to equal negative b, so negative 2, over 2 times a. So in this case, my axis of symmetry is negative 1. So that means my vertex I can find pretty easily, because the x value of my vertex is a negative 1. And all I need to do is plug this back into the original equation. So negative 1 squared is 1. 2 times negative 1 is negative 2. And then we have negative 8. So in this case, my y value of my vertex should be negative 9. My y-intercept, in this case, is going to be the point 0, negative 8. And so once again, I will plot these points, but I'm also going to go back to my table using my graphing calculator or Desmos to get some key points. So let's just see what we have so far. -1, -9 puts me way down here. And then 0, -8 puts me here. I can mirror it over my axis of symmetry, so I've got these 2 points so far. But I need some points closer to my x-axis to find my solutions. Well, if I look at my table of values here, I should get that at x equals -4, my y value is 0, and x equals 2, my y value is also 0. And so I can plot those points as well. 2, 0, -4, 0. And so my parabola looks something like this. Oh, kind of messed that one up. There we go. That's better. And so this is my parabola. And I know my solutions take place here and here. So x equals -4 and x equals 2 are my solutions to problem 8. Problem 9 is done the exact same way. So plugging in the values, I know that my axis of symmetry for this one is going to be a little messier. It ends up becoming -1.66, or in this case, 5/3. That means in my vertex, when I plug that in, also kind of a messy decimal, you've got -1.66, and then your y value ends up coming out to be -16.3. So this one's actually off the graph a bit. And then, but if you look at your table of values for this one, and you plug it in your calculator, when x is -4, you get a 0 value for your y. The only problem is you can't see the other y value is 0, so what you have to do in this case is kind of think about what's happening. Your axis of symmetry is at -1.66, which is kind of here. At -4, you have a point for your graph. This is a solution. Well, there should be a mirror image point on the other side. And so this isn't exactly a great problem to solve graphically, but we'll mirror it over, and that puts us at the point right around here. And so in this case, your solutions to this problem set, or this graphing problem, is going to be -4 and 2/3. So this one's probably not the best one to use, but if you use Desmos, you'll find your answer really easily for this one. So on questions 10, 11, and 12, you're solving using the quadratic formula. So keep in mind that the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And so we're going to try to solve these using the quadratic formula. So for question 10, our a value is 2, b is -4, and c is -6. And so we'll plug our values into the quadratic formula. So we've got 4 plus or minus -4 squared minus 4 times 2 times -6 all over 2 times 2. When you evaluate what's underneath your radical there, or your square root, you should get 4 plus or minus the square root of 64 all over 4. Well, in this case, you end up with 4 plus or minus the 8 over 4. You create your two equations. You've got 4 plus 8 over 4 and 4 minus 8 over 4. Well, 4 plus 8 is 12. 12 divided by 4 is 3. So one of your solutions is 3. And then 4 minus 8 is -4 divided by 4 gives you -1. So one of your solutions is -1. So for this problem, your solutions are 3 and -1. All right, then we can move on to question 11. Same idea here. Your a value in this case is 1. B is 2, and C is negative 8. So we'll plug this into the quadratic formula. We've got x equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 8. All of that over 2 times 1. Well, in this case, we will evaluate what's underneath the square root, and we get negative 2 plus or minus the square root of 36 all over 2. Square root of 36 we know is just 6, so I've got 2 plus or minus 6 over 2. I'll create my two equations, and in this case I've got 2 plus 6 over 2. Well, 2 plus 6 is 8, divided by 2 is 4. And then for the other one, I've got 2 minus 6 over 2. So 2 minus 6 is negative 4. Negative 4 divided by 2 is negative 2. So my solutions here are, I seem to have messed up there. I forgot this was a negative 2 outside. So let's fix that real quick. So the top one here is negative 2 plus 6. So that equals 4. 4 divided by 2 is 2. So we have positive 2, sorry. And then the bottom one, this should be a negative 2 minus 6, which is negative 8. Negative 8 divided by 2 is a negative 4. There we go. So our solutions are 2 and negative 4. Question 3, same idea. We want to use the quadratic formula. So we've got A, B, and C. And so we plug in what we know. Well, x equals negative 10 plus or minus the square root of 10 squared minus 4 times 3 times negative 8. All over 2 times 3. Well, evaluating what's underneath the square root, you're going to get negative 10 plus or minus the square root of 196 all over 6. Well, the square root of 196 is 14, so I've got negative 10 plus or minus 14 over 6. Well, I'll create my two equations. I've got negative 10 plus 14 over 6, which in this case is going to give me negative 10 plus 14 is 4. 4 divided by 6 is actually just going to be 2/3. So one answer is 2/3. And then I do the same thing again. I have negative 10 minus 14 over 6. Well, negative 10 minus 14 is negative 24. Negative 24 divided by 6 is negative 4. So I've got 2/3 and negative 4 as my two answers for question 12. So for questions 13, 14, and 15, you can use any method you want to solve them. You can use graphing. I'm pretty certain they're all factorable, so you can use factoring or you can use the quadratic formula. So if you want to know how I tried to solve them, try checking the other answer key or asking me. But I'll just put the answers up here so that way you can kind of check your answers to see if you got them right. So for question 13, there's actually only one solution, and you get x equals negative 1/2. For question 14, you should get two solutions, and it's going to be x equals 4 and x equals 1. And then for question 15, you get two solutions as well. You get x equals 2 and x equals a negative 1.8.